Back. In the previous session, session 2, we looked at using remote sensing to monitor endangered species to support the monitoring of endangered species and designing measures to reduce their interaction with potential human activities. And we also look at how remote sensing was utilized with modeling and combined with in situ monitoring data for modeling and forecasting of harmful algal bloom, with example from the Lake Erie. So in this third session, we're going to be looking at the usage of remote sensing in sea level rise monitoring and climate risk assessment, coral health monitoring, and finally we look at some of the possibilities that are available and likely to be available going forward within remote sensing for water resource management. So welcome, and let's get started. So let's look at the first example of sea level rise and coastal flooding impact. This is a tool developed by the NOAA in the United States. Combines huge data sets from various platforms, remote sensing platform, from LiDAR data to land cover data and so many much more. So within this platform, they utilize elevation, especially this is one of the most important data set for this kind of modeling operation and decision support system. So they use elevation data derived from the coastal topographic LiDAR to derive a benthic terrain model and some other digital elevation model for the land area. So this tool was developed to provide a preliminary look at sea level rise and coastal flooding impact. So in the coastal regions of the United States, this tool can be used to visualize what are the likely impact of sea level rise and coastal flooding as a result of climate change. So providing an opportunity to assess climate change risk. So this is a very useful tool, and it's utilized a whole lot of data, petabytes of data from remote sensing, different and variety of remote sensing platform. So if we look at this point, I will move to the platform so that we take a look at what it has to offer. So let's have a look. So the platform has a variety of tools. Okay, so for example, this is an area of Florida, Tampa, Florida, and we can see, if I zoom in closer, you'll see satellite imagery showing the different land use and land cover across the area. You can see oil and gas installations along the coast. You can see port facilities and so on. So there's a whole lot of facilities. I think this is probably a train station. So we can see a haulage service where people come to pick up things from the port. So this is one of the aspects you can look at from the sea level rise viewer. So this platform provides you with the opportunity to have access to huge data sets showing different land use and land cover and land use across the area of interest. So let's look at an example. So if we click on Tampa Convention Center and we want to see the scenario that what happens as sea level rises. The current level is around, this is the current level, the MWHW as the mean, okay, mean higher water level, so it's around 0.5 or so, or even less than that. So as we move on, as we simulate that, what happens if water level gets to 3 feet? We can see that there is already inundation in this the Tampa Convention Center. This is the Tampa Convention Center. So this tool is able to give us a kind of realistic simulation of what happens if water level rises to 3 feet. What is likely to happen? Part of the building is likely to be inundated. As we go higher, more and more of the area along this coastline, okay, it's likely the Tampa General Hospital, we can see it's clearly at 6 feet, it's almost all going to be inundated. And the same goes for many areas, many of the residential areas surrounding Tampa General Hospital. So this is a very useful tool that can give us an idea of what is likely to happen if a scenario unfolds. So with the tool also, we also see areas, we capture areas that the model being used have low confidence in terms of the level of inundation. We're not too sure about what the model is producing. So that gives you a kind of error, the level of error in the model. Okay, we can see marsh migration, which means where are the marshes likely to migrate to as sea level continues to rise. Okay, where do we see developments, low intensity developing? Those places that are darker brown, marshes are likely to continue to move to those areas, and the areas that are in white, okay, like here, we're likely to see high intensity development of marsh in that area. The idea is that over time, as sea level continues to rise or as land use continue to change, marshes actually move to areas that they likely find more conducive to survive. So as human being continues to change the landscape, marshes will also move to find suitable habitat, and that can give us an indication of where are the places that is more suitable for inundation, because marshes thrive on submergence of the land. So areas where there is saltwater intrusion and there's submergence of the land for a particular period of time, especially wetlands, there is likely to be marsh migrating to those places. So this gives us an idea. Then also, if we look at high tide flooding during high tide, where are places that are vulnerable to inundation, we can see all these places in red, shallow coastal flooding area. So those are the areas that are more vulnerable to high tide flooding. So this is a very useful tool, and you need to explore it extensively to see how it can help to support decision making. So looking at that now, it becomes clear to us that this is a tool that will help decision makers. It's a decision support tool to see the effectiveness and sustainability of their current development intervention, thereby supporting them in changing direction or coming up with better ideas about how to assess their climate risk. So this is a very useful tool that is extensively based on the use of remotely sensed data. So let's look at the next example, live coral cover mapping. Coral are very important in the marine ecosystem, and in order to monitor them, their health, one of the most important tool that is, or indicator that is used, is live coral cover. It's an important indicator to tell us how the coral reef are doing. So if we want to know where there is coral reef degradation, we can use live coral cover to measure where this is going on. Okay, so